Good morning. This is Professor Gardetto. I'm going to put together a little mini video here for you to work through some problems on homework number 8. So number 8 starts with some problems that ask you to do factoring. Okay. If you remember the distributive property, it's kind of the reverse of what the distributive property is. So let me just give you an example here that has nothing to do with this problem. Let's say we had a 2 out here and we had x plus 3 inside the parentheses. Okay, so we remember what to do for the distributive property. We multiply this 2 times the x, so we get 2x. And we multiply the 2 times the 3, so we get 6. And this was our answer. If it asks us to multiply, we multiply that 2 out and we get 2x plus 6. What factoring is all about is it's going in reverse. So instead of this being the question and this being the answer, what we do is say this is the question and the answer is going to be the factored form of this. So we want to go from the factored form or from the non-factored form to the factored form. So this greatest common factor business is the number that goes into both terms. That's the greatest. So the greatest number that goes into 2 and 6 is 2. So that's called the greatest common factor. Now you have to draw your own sets of parentheses. And we want to put inside the parentheses what you'd multiply by 2 to get what your question was. So what times 2 is 2x? Well, 2 times x is 2x. And if you take out a 2 from a 6, if you factor out a 2 from a 6, you end up with 3. So you can check to see if you're correct by doing the distributive property in your head. If we multiply 2 times x, we get 2x. If we multiply 2 times 3, we get 6. So question 1 asks you to find the factor out the greatest common factor, and it gives you 6w minus 4. So we have to look at both terms, 6w and 4, and we have to think of a number that goes into both. That's the greatest. Okay. Well, there's only one number that goes into 6 and 4, and that's 2. So that happens to be the greatest common factor. Now, when we take out a 2, what do we get? What do we have left? What do we have left? And another way of saying that is, what do you multiply by 2 to get 6w? A 3w, right? And then what do we multiply 2 by to get negative 4? So we put that in our box here. I'm not going to take time of putting all these in there. We talked about this yesterday in the mini video. That's the exponent. There's no exponents here, so we just put 2. We use the parentheses. I'm just using my keyboard. 3w minus 2, and then in the parentheses. Make sure you end your parentheses as well. Okay. So checking our answer. It'll give you a little green check mark, and then we can move on. Okay. The first few problems have you factor out the greatest common factor. Okay. You want to make sure it's the greatest number that goes into your terms. Let's look at one that has some variables. Okay, here we go. Here's one that has some variables. So factor out the greatest common factor. It's 30x to the 5th minus 45x to the 3rd. So let's look at the numbers first. Okay, the numbers 30 and 45. What's the largest number that goes into 30 and 45? Well, you might think, well, 5 goes into 30 and 5 goes into 45. Okay, but there's a larger number that goes into 30 and 45 besides 5. You guys can think of it. It's 15. 15 goes into 30 because 15 times 2 is 30, and 15 goes into 45 because 15 times 3 is 45. So you got to make sure it's the greatest. Okay, That's what this word greatest common factor. Because common factor, there's a lot of common factors, but 15 is the greatest common factor. Okay, now for the variables, okay, you have x to the fifth, which means you have 5x's. And you have x to the third, which means you have 3x's. So how many x's are in common? Basically, something that's in common. If you have something in common with somebody, you do the same thing. So it's got to be the same. What's the same on both sides of this line? Well, there's 3x's on both sides of this line. So the greatest common factor has a 15, but it also has an x to the third. Another way you can think of it is it's always the lowest exponent. If you have x to the fifth and x to the third, it's going to be x to the third. It's the lowest exponent that you have. Okay, so now we're going to draw our set of parentheses. And we have to put two terms inside the parentheses because there's two terms here. So what times 15 is 30? 2. And what times x to the third is going to give you x to the fifth? So that's going to be x squared. And minus, what times 15 is 45? 3. And then we don't need to put any x's here because we have the x cubed here. Okay, remember, you can always check. Before you put your answer in the box, you might want to just do the distributive property. Check to see if when you multiply these two together, you get what you started with. 15x cubed times 2x squared is 30x to the fifth. And 15x cubed times negative 3 is negative 45x cubed. Okay. Go ahead and clear this. Okay, so starting on 9, it's asks you to factor out a negative. So when you factor out negative once, it's actually telling you what to factor out, starting on number 9. So if you factor out a negative 1, well, think about this. If you factor out a negative 1, what does that do to all of these signs? If you factor out a negative 1, think about it as just dividing by negative 1. If you divide something by negative 1, you change the sign. So this becomes a 2t squared. This becomes a positive 7t. And this becomes a negative 5. It changes the sign. That's all factoring out negative 1 does, is it changes the signs. That's all you have to do there. It tells you the next few problems tell you what to factor out. Okay, they tell you. This one here, number 10, tells you to factor out a negative 1. Some of them are, okay, here's factor out a negative 6a cubed b. So if you factor out a negative 6, that's going to change all of these signs. But then we have to divide by 6. So let's look at this one. Factoring out a negative 6. So we take negative 6, a cubed, b, and we put it outside. If it says factor it out. That means it's outside the parentheses. Okay, so now take negative 18, divide by negative 6, you get a positive 3. A to the second power and b. So it's a to the second power times a cubed is a to the fifth, and b times b is b. No, I want b to the fourth. So if I have a b here, I need to have b to the third. That's your first term. You got to be careful with the exponents. Remember, yesterday we talked about adding exponents. So 3 plus 2 is 5, and 3 plus 1 is 4. And notice the sign changed. The negative 18 becomes a positive 3 because I divided by negative 6. Whatever number's out here, that's what we divide by. So Next, we take negative 24, we divide by negative 6, so this is going to be a positive. And this is going to be a 4a. And we don't need a b. We don't need a b because we have the b out here. So just 4a. And then we have a minus 18, so this is going to be a plus. And this is going to be a 3. And that's it. That's what we put in. Okay. Let me clear the screen. And let's see, I wanted to go over 14. Let's go 14. Okay, so 14 looks a little different because they have parentheses. But notice what's in the parentheses is the same thing. It's the same thing. So if it's the same thing, it must be common. If it's the same, it's common. So the way we factor out this one is we just take out exactly what we see that's the same. It's 8y plus 3f. I'm just going to put it in parentheses the same ways it has here, but I only have to write it one time because it's common. Now I have to draw my own set of parentheses. And then what is it left? It's left, there's a 3a, there's a 3a, and there's a plus 2. The 3a comes from right here, and the plus 2 comes from right here. And then I can just leave it like this, that this is factored, okay? Basically, you're creating a multiplication problem when you're factoring. This is a multiplication problem. This is not a multiplication problem. I mean, you would multiply here, but this is an addition problem because there's a plus. This is a multiplication problem because there's understood to be multiply right there. Okay. You're going to see that 14 through 18. You're going to see those types of problems. You're going to have binomials. Okay. Which leads us to number 19. Okay, so this is called factoring by grouping. It says factor the polynomial by grouping if possible. Select cannot be factored if applicable. Okay, so when we have polynomials that have 4 terms and we want to factor by grouping, what we're going to do is we're just going to group the first 2 together. So I'm going to draw a set of parentheses like this, and I'm going to group the last 2 together. So I'm just going to draw my own parentheses there. It's always first 2, last 2. Okay? Never group the first 3 together. Always be fair and make it 2 and 2. Okay? 2 terms and 2 terms. That's your first step. Draw the parentheses. Step 1. Because you're not going to see the parentheses in there. Okay. Step 2, you're going to factor out the greatest common factor in each of your sets of parentheses. So look at the first set, VW plus 4W. What's common? Well, there's only a W common. So I'm going to take out a W. I have left V plus 4. Now I do the same thing with the second set of parentheses. But see this plus sign right here? That plus sign goes right here. Okay, so I'm going to take out a positive 2. 2 goes into 2V, 2 goes into 8. Take out a positive 2 and watch what happens. Watch what happens when you take out a positive 2. I have V plus 4. That was by design. Okay, they're not going to give you too many problems that cannot be factored. How do I know this can be factored? I know this can be factored now because I have the same thing. Here, I'll change colors. I have the same thing here and here. If I didn't have the same thing here and here, then it cannot be factored. These are common. So now I write it this way because this is not factored yet. Okay, Step 3 is W plus 2 and v plus 4. W plus 2 right here, and v plus 4. Now you could also write it the other way. If you wanted to write it backwards, you can write it backwards. I can write v plus 4 first. I can write v plus 4 first, which is the common factor, and then I could write w plus 2. When you're multiplying, it doesn't matter the order in which you multiply your binomials. Okay? You're going to get lots of practice doing these because the assignment's 30 problems, and starting on 19 is all the problems that you're going to have to factor by grouping. Okay? Let's go over another one. All right, so let's look at this one here. Remember that the whole goal of factoring by grouping is to get those in parentheses the same. All right, so let's see. First step, let's draw the parentheses. Okay. Okay, so I'm going to take out the common factor here, a 3, and let's see, it's x squared, and then there's 6xy, so that's going to be 3x. 3x is common, and we're left with an x plus a 2 and a y. Okay, 3, and I'm just checking using the distributive property in my head here. 3x times x is 3x squared. That checks. 3x times 2y is 6xy. Okay, now be careful. There's a minus right here. That means that this is going to be a minus. Okay, there's a minus right there. I kind of covered over. There's an xy, and there's a minus 2y squared. So the common term, there's no number that's common, but there is a y there, and there's a y squared there. So I'm going to put a y. Now, if there's a minus there, that's going to act like a negative y. So you remember when you factor out negatives, what happens is it changes these signs. So negative x, now negative y times x is negative xy. And now here's where you really have to be careful, because you're going to see a negative right here. That negative becomes a positive, because if you take out a negative y times a positive 2y is the negative 2y squared. And that's really what you want to happen. You want to have, remember, we want to have these two terms to be the same. Those are the same, x plus 2y, x plus 2y. Distribute this negative y to each of these terms, and you'll get negative xy, and you'll get negative 2y squared. Okay? So then we can do the last step. Take out the common factor, x plus 2y, and then write your binomial, 3x minus y. Your binomial that you write is just this term and this term. Just make sure you write the sign of that term as well. That's where that minus y comes in. Okay? Now, if you remember the box method from yesterday, if you wanted to double check before you put your answer in, this is something that is optional. You don't have to do this, but if you wanted to write x plus 2y up top here, and you write 3x minus y on the side here, and you do the multiplication, so you get 3x squared, you get 6xy, you get negative xy, and you get negative 2y squared. These four terms are the same four terms as you have here. It's the same four terms. So you're not doing any solving. What you're doing is you're writing a problem a different way, and it's called factoring. Okay. Um, Good luck on homework 8. Stay tuned for the Zoom session later on this morning. I would watch the entire Zoom session before attempting homework 8 because I'll be going into greater detail. Remember, this is just a mini video, just a small little clip, which I will be discussing in greater detail during our Zoom lecture. All right. Have a good day.